Atchison. I work at a company called New Relic, and New Relic is a SaaS platform that provides application performance monitoring for both cloud-based and on-prem applications and infrastructures. Before I start, we are a public company, and I just want to make sure everyone understands that the information I'm giving you shouldn't be used to buy or sell our stock. I'm not giving you advice on buying or selling stock. Please keep lawyers out of my office. I very, very much appreciate that. But like I said, my name's Lee Atchison. I'm a principal cloud architect for New Relic, and I've been in the industry for about 28 years. And 7 years of that, I was working at Amazon.com, both in Amazon as well as in AWS. I was a senior development manager, and I built Amazon Retail's first app store, which was used for downloading software and video games for PC-based games. And I moved to AWS, and there I was responsible for building a service that AWS provides called Elastic Beanstalk, which some of you may be familiar with. It was their PaaS offering, their first PaaS offering. And so I have a fair amount of industry experience in the cloud. And 4 years ago, I moved to New Relic, where I've been playing the roles of architecture lead and cloud architect and various roles like that within New Relic. I do have a specific expertise not only in cloud computing, but in building service and service-oriented architectures, and in scalability and availability are my two primary focuses. And I'm actually writing a book on the topic, which is coming out in June, called Architecting for Scale, being published by O'Reilly Media. And so I spend a lot of my time going around talking to groups about using the cloud and building highly available and highly scalable systems. But today I want to talk about how we all want to build apps, better apps. We want to build better apps faster. And how do we use the cloud, or how can we use the cloud in order to build our applications faster and better? There's two primary ways that most people use the public cloud. And that is, use the public cloud as a way to create better data centers. I call that the static approach, the static way of using the cloud. And then there's using the cloud to create a more dynamic environment. And I want to talk about both of these independently. Let's talk first about the cloud as just another data center, but a better data center. So what does it mean? What do I mean when I say use the cloud as a better data center? What I mean is we use the cloud in such a way that we allocate cloud resources like servers and such. They're allocated to specific uses, just like in a traditional data center. You create, you're building a new service, you need 20 servers for it, you allocate 20 servers for that service. Very static way of building up your cloud infrastructure. Very common way though. The provisioning process is faster, and that's one of the primary draws for doing this. But the lifetime of your components, lifetime of your servers that you've been provisioning this process are relatively long. Might be days or weeks, months, or even years, as long as you need the service for, and it may be shorter than that, but they're in general relatively long duration resources. And another reason, excuse me, I'm sorry, and capacity planning is still an important part of dealing with the cloud in this model. You're still allocating resources very statically, like you would in a data center or in a private cloud. And the planning of how much resources you need, and the billing and the planning and the budgeting for all of that is still an important process. So you still need to consider those issues and deal with those issues. So why would anyone use the cloud in this manner? Well, there's several reasons why, of course. One is you can add new capacity quicker. It's very easy to bring up new capacity faster, easier, quicker, et cetera, which is important for building applications faster. You can improve your application availability by bringing up whole new data centers quickly and easily that you can't do in a traditional data center approach, or is much more expensive and much more time consuming. And of course, compliance reasons. We've heard during the last discussion, as well as other discussions earlier today, about how the cloud can help you with compliance issues around where your data is stored. I'm thinking things like EU safe harbor rules and some of the new rules in Australia for safe harbor requirements, or backup data and geographic locations, et cetera. Well, when we think about using the cloud in this very static model, and we talk about our dev part of our organization and our operations part of our organization. And they may be parts of our organization, or we may have a DevOps culture and the different roles that people play. But let's look at those two roles, the dev role and the ops role. Who's impacted by considering using the cloud as just an extension of your normal data center approach? The answer is mostly it's your operations organization, because they care about things like scaling your fleet, and adding servers and adding redundancy and adding those sorts of capabilities. And they care about how those services work in the cloud. Your development organization pretty much doesn't care less, right? I don't care as a developer, I don't care where operations runs my service as long as they run my service. They don't typically care in this model anything about the cloud, which is kind of an interesting thought. But again, in this model, this is primarily used to get your applications running faster. Well, I'm obviously come from a monitoring company, and so one of the questions we get asked a lot then is, when I move to the cloud, when I do a lift and shift of my application to the cloud, which is really what we're talking about here, how do I monitor my application? The answer is, you can monitor your application in exactly the same way that you do in your own data center, especially if you're using a cloud-based or a SaaS-based monitoring solution. You don't have to build a new monitoring system into your product. You don't need to build a new monitoring solution. Your existing solutions will work just fine in this model. But I hear the question that gets asked is, but what about CloudWatch? I mean, there's already monitoring in the cloud. Why do I need another monitoring solution on top of that? Well, CloudWatch solves one part of the problem. It monitors the low-level infrastructure for you. It monitors the virtual hardware. But it doesn't do anything for monitoring the rest of the server or the rest of the application running on the server. You can't even get basic information about memory utilization out of CloudWatch, or file system utilization, or processes. It doesn't know anything about those sorts of things within it. It only knows about the low-level virtualization layer and nothing more. So in order to really understand how your application works, you have to have a monitoring solution that also looks at the server and the application as well. Of course, New Relic does this, but there's other products that do this as well. But you really need both an application and server level monitoring product as well as the CloudWatch monitoring in order to really fully understand how your application is performing when you move it to the cloud. That's the static world. What I'm really here to talk about is the dynamic cloud, and that using the cloud and using the native capabilities of the cloud to build more dynamic applications. So what do I mean by a dynamic tool for building dynamic applications? What I mean is using the cloud in such a way that you only allocate the resources that you need at the moment you need them. You allocate and deallocate resources on the fly, and that the resource allocation process isn't a static operation that the ops team does. They don't provision resources and add resources to a spreadsheet for you, but it's a dynamic process that's built into the core nature of your application. Your application knows and understands what it's involved and what resources it needs to operate. Resources are allocated, consumed, and deallocated, and this is under control of the application, not of the operations team. I'm going to take a little digression from strictly talking about the cloud and talk about Docker for a moment, and you'll see why. But Docker and Docker usage patterns mimic very closely the dynamic cloud usage. And you'll see as we go along here how that's true and why that's true. But let me take this digression and talk about Docker a little bit. So as I mentioned, we're a SaaS-based performance monitoring company. And about 6 months ago, we decided to take a survey of our customers that are using Docker, because we monitor the Docker containers for them. So we looked at all of the Docker containers that all of our customers were running. We evaluated something in the neighborhood of, I think it was 10 million Docker containers. And we wanted to see how long those Docker containers were running for, individual Docker containers. And what we found was, so this is a chart of, on the vertical axis, a count of a number of containers, and on the horizontal axis, how long the containers ran for. We found the average duration of running for a Docker container is 83 days. Seems like a long time. It's still shorter than the lifespan of most servers, even cloud-based servers, but it's a lot longer than you would normally think. And the longest Docker container was running for almost a year. What was interesting is we had about a year's worth of data, so I expect there were longer instances, we just didn't know about them. But this is interesting, but the real interesting data point is that very left-hand mouse column there, which represents the number of Docker containers that were running for less than 1 hour. We took that one column, expanded it out, and found that almost 1 million of the Docker containers, roughly 11% of all Docker containers that we were monitoring, ran for less than 60 seconds. So these are containers where there was an application that was performing presumably some valuable business logic for their application, that these containers provisioned themselves, performed some operation, and deprovisioned themselves all within 60 seconds. Forget about provisioning servers for lasting months and years. We're talking about servers that last minutes. And that was kind of a revolutionary thought. But what's interesting is that same principle applies within the use of the dynamic cloud as well. When you think about things like auto-scaling in EC2, and some of the mobile monitoring and the mobile technologies that go on, and how mobile devices come and go off as resources on the internet, as well as Docker, as well as things like queues and notifications and dynamic queue creation and dynamic routing of data and all those sorts of things. What you realize is in a truly dynamic cloud-based application, you're allocating resources and moving resources around very quickly so that the resources you care about and the resources that you monitor, the resources that you want to make sure are functioning the way you want them to do, aren't just sitting there all the time. They're coming and going on a regular basis, sometimes very, very quickly. So monitoring these dynamic resources is a very hard thing to do. So when you think about a dynamic application, you can still use CloudWatch to monitor the low-level virtualization of your application, right? That still works. You can still use application performance monitoring as you traditionally think about it to monitor, the application and the overall structure of the application itself. And all that still works, but it's not completely covering your application anymore. Your application has this new responsibility, and that's the provisioning process. Whether explicit or implicit, your application is involved in provisioning resources dynamically at a very rapid rate. And how do you monitor that? How do you monitor and keep track of things that were there 10 minutes ago but aren't here anymore? How do you monitor Docker containers that only survive for seconds? And the answer is you have to have a different approach for monitoring. You still need the capability to monitor the individual components, resources, services, applications, servers, everything else. You still need that. But now you also need to manage the life cycle of these dynamic components. You need to know how many of this type of resource were created when, how long did they last for, and did they have any problems, and what period of time they covered for. Because it matters when you're looking at a problem that occurred on your application 2 hours ago. You want to know what resources were running then, not resources that are running now. So back to this diagram where we said from a static standpoint, it's primarily your operations organization that's concerned about how you use the cloud. And now let's throw some of these dynamic cloud considerations in. And what you find is your operations team is no longer comfortable with the cloud because they're no longer in control with what's going on. Resources are coming and going that they're expected to know about, they're expected to manage, they're expected to monitor, and they don't even know where they are. They don't even know what they are, and they keep coming and going very, very rapidly. But at the same time, the role of the development organization has changed as well. Now, they no longer don't care. They care intimately about the cloud provider you're using, which one you're using, how you're using them, which resources you're allowed to use and not allowed to use, because they're implementing those technologies deeply within the bowels of their application. So we're moving up a curve here, or down on this slide, moving from a world where your operations team drove how you used the cloud, and your development organization didn't care, to a world where your development organization cares how and where you use the cloud, and your operations team is scared stiff of what's going on. It's a very different world for us to be in. It's a scary world for most of us. And the reason why this is going on is because the world is changing out from underneath us. In order to build faster applications and to build them better, you have to move from the slow provisioning process of a traditional data center to a faster cloud-based provisioning process, and now into using some of these dynamic cloud capabilities in order to keep up with what your customers require. The way you're doing things is changing, and you have to be able to keep up with this. And this is really the secret of what's going on with the cloud in what I call the second generation of the cloud growth that's going on right now. So EC2 servers made provisioning of servers easier. So now you can provision servers in minutes versus days or weeks, as I've heard other people say. Docker containers make provisioning of essentially processes quicker and easier. You can now provision virtualized processes that will run on your servers and provision them in seconds and get large numbers of them running very, very quickly. And monitoring all this and understanding how this works is hard. And it's hard today, right now, but it's getting harder. Because there's even more technology that's coming out that's making it even harder for this to happen. Now we're not provisioning servers or provisioning processes, we're provisioning functions. AWS Lambda is, I think anyone here who's gone to an AWS conference recently will know that this is their #1 technology that they're promoting right now. And for a good reason, because it solves a lot of problems for their customers. You will be hearing a lot about Lambda in the next couple of years. And if your development organizations aren't already starting to consider using Lambda, they will be very, very soon. Let's talk a little bit about what Lambda is and why it's important. Basically, like I say, it's a dynamic cloud technology. It provides essentially an event-driven compute technology. But it does it in a way that requires no infrastructure to provision. You'll hear some people call this serverless technology, and then other people say, well, there's still servers there that you just can't see them. Well, but the fact that you can't see them is exactly why Lambda is so powerful. Yes, these things run on servers, but you don't need to know which servers they run on. You don't need to know how many servers are needed to run them. And you don't have to provision or own any of those servers. That's all hidden from you on a massively shared infrastructure. You don't need to know anything about the number of these things that you want to run, when you want to run them, or anything. There is no provisioning involved. So calling it serverless, yeah, is a little bit of a misnomer, but calling it provisionless is what's really the critical distinction here that makes Lambda so powerful. Virtually no startup is shut down. And essentially the way they work is they run in response to a state change. And they're designed to perform very, very short, quick actions. Typically what happens is you write a Lambda script so that it sits waiting for something to happen in your cloud environment. There might be a file that gets written to an S3 bucket, or someone makes a call to an API gateway, or a database write occurs to it updates a table or a row in a table, or an event gets written to a queue. Something like that happens. And in AWS terminology, they call this the trigger. This is the thing that causes the Lambda script to execute. This will, when one of these triggers occurs, when one of these files get written or whatever the action is that you set up as a trigger, it causes a Lambda script to be instantiated, to be provisioned on the spot, executed, and when it's done executing, it is automatically deprovisioned and it automatically disappears. The Lambda script typically will take that event, whether it's creating a file or whatever, and perform some actions in it. Like a simple example might be if you have a bucket that you're uploading photos into, the Lambda script may take those photos and create smaller versions of them for thumbnails. That sort of thing is a sort of thing that Lambda is really well designed for. But what's interesting is it does this dynamically, and it'll create as many Lambda instances as are necessary to handle as many of the events that are coming in at whatever speed the events are coming in at any scale. You don't have to know the scale. They have enough capacity. It's a massively shared infrastructure. You're sharing capacity with all other Lambda or AWS users. You don't have to know how many of these you could possibly have running at a time. You can scale to practically limitless number of these things that can be run simultaneously. So how do you monitor these things? Now you're talking about applications that aren't using resources like servers that are provisioned in the course of days or hours that run for years or months. You're not talking about Docker containers that provision over the course of a few seconds or a minute and run for seconds or a minute. You're now talking about provisioning instances that create and run in 10 milliseconds. Very, very fast resources. There's no way that you will ever care about the run of any single one of these scripts unless it causes an error or something. But what you care about is the aggregate of all of these. You care about how many of these things are running and how long they take to run. And is there some optimizations you can make to the script that make them, on average, run faster? And how many errors are you finding with a script? And typically what you're seeing is that you think about Lambda scripts no longer about a piece of your infrastructure. They're not a server that you're provisioning. They're more like an application that you monitor. They're more like a web application. All the same things you care about with a web application, you care about with a Lambda script. But it's a piece of infrastructure. So how you think about these things is radically changing. And again, change is speeding up. Now you're not talking about managing resources in a spreadsheet of servers that are lasting for months. You're managing things that are running for milliseconds. And that is a whole different world. Used to be in the olden days, long ago, that all you need to do to monitor your application is look at the server. If the CPU utilization stayed relatively flat and the memory utilization stayed relatively flat, you didn't have a memory leak and you ran out of memory in your server, you knew pretty well your application was running fine. You could pretty much ignore it. It's not true anymore. The world is so dynamic that that information is not enough. You need to know how your application is working in totality. You need to know how your entire infrastructure is working. You need to know how everything, both your cloud-based resources and your on-prem resources are working together in harmony in order to get a full picture of how your application is working. And only by having this full picture can you trust going to sleep at night and ensure the application continues to run. So that's all I had to say. I do want to say that this discussion, as well as other discussions like this, are in my book, and I promise you can look at the URL there. It is available from O'Reilly. I'm also going to be out at the Velocity Performance Conference, which is in 2 weeks in Santa Clara, and I invite, if you're there, to look me up there. We'll be giving out pre-release copies of the book, as well as later on today, I'm giving another talk on high availability. That's in the room 1A04, which is one of the hot track rooms over there. And this is a talk about how concepts I learned in learning how to fly model airplanes applies in keeping highly scaled applications up and running. This is much more of a lighthearted talk, but I encourage you, if you're interested in some of these topics, to come to that talk as well. And that's all I had. Thank you.
That was great.
Thank you.
So there you go. That was tremendous. That might have been the talk of the decade, right?